Hello children, in today's video we are going to solve some previous board numericals that comes from A part of sound chapter. Okay, so this is one of the questions that came in the year 2018. Okay, so you can please pause the video and write down the question in your notebook. Okay, please note down the question, it's not there in your book, then we'll start solving. Okay. After noting down the question, let's go to the solution now. Okay. You have to read the question carefully and as I told you, draw a diagram for this, that will be better. Okay. A person is standing at the seashore. Okay. Let's take this person as person A. He is standing at the seashore. An observer on the ship which is anchored in between a vertical cliff and the person. Means there is another person on this ship, okay, and where the ship is, it's between a cliff and this observer on the seashore. Read again clearly. An observer on the ship which is anchored between a vertical cliff and the person on the shore. So this ship is anchored between the cliff and the shore and he fires a gun. This man has a gun in his hand. Okay, let's take this as his gun. So he fires a gun and so this man hears two sounds. One after 4 seconds and the next one after 5 seconds. And then they've given the speed of sound as 330 meters per second. And we are supposed to calculate the distance between cliff and man at shore and then cliff and the observer on the ship. Hope you understood the question, children. So this is, let's take this as the gun, okay? So I think this is better. So this man, let's take B. Okay, the man on the ship who is firing a gun, let's name him as B. Now, let's start solving. First, let us assume the distance between the cliff and this man as x and the cliff and this man as y. This is the first thing you're going to do, okay? The distance between cliff and the first man, the man who fires the gun, is x and the distance between the cliff and this man, let's take as y. Okay, now we are going to have two cases. First, the sound heard after 4 seconds. Second, the sound heard after 5 seconds. Now, the sound heard after 4 seconds would have been the sound that has traveled from here to here. So this man fires the gun. So the sound he would have heard, the first sound that he hears is the direct sound that comes from this gun. Okay. So how much distance that sound has to travel? This much distance. And what is this distance? Y minus x. Y minus x. Okay. So for the first sound, the distance traveled is y minus x and time taken is 4 seconds. And speed of sound is given as 330 meter per second. So, we know that V is equal to distance upon time. Now, if you remember, I told you for equals the formula for speed will be 2d by t. But why we are taking only distance by time here? Because this is the direct sound that he is hearing from this gun. It's not the echo, the direct sound. Okay. So, distance is y minus x upon 4 is equal to 330. Okay. Now cross multiply it. 3 4s are 12. 3 4s are 12. 13 is equal to y minus x. This is one equation that you will get. Now come to the second case. The sound that he is hearing after 5 seconds. Now listen carefully. That sound would have been the sound. Okay, see when he fired a gun, the sound is going to travel in all directions. He heard the sound after 4 seconds. Now, the sound that went in this direction would have got reflected from the cliff and come back back to the man, that is the second sound. The sound that is produced by him goes, hits the cliff and comes back to him, and that is the second sound that he heard after 5 seconds. So, in this case, what will be the distance traveled? The second case, the sound has to travel a distance of x. Okay, it goes here, hits this and comes back here. So, x plus y. Once again, I'll tell you, the second sound will be the sound that is produced from the reflected sound from the cliff. Now, how much distance that has to travel? It has to go from here to here, hit this cliff and then travel all the way back to this man A. So, x plus y. So, in this case, distance is x plus y and time is 5 seconds and speed is 330 meter per second. So, again, velocity is distance upon time. Here, again, we are not taking echo, that is sound, he produces sound and he hears it. No, we are talking about one person producing a sound, it is heard by somebody else. So that's why you took x plus y. So again, it will not be 2 into d by t, it will be just distance by time, that is x plus y by 5, or 330 is equal to x plus y by 5, or x plus y is equal to 330 into 5, 3 5s are 15, 3 5s are 15, 16. So, x plus y is equal to 1650. So, you've got two equations now. We can solve those two equations and get the answer. First equation is y minus x is equal to 1320. And the second equation is y plus x is equal to 1650. Now let's add these two. So it will be 2y is equal to 2970. Therefore, y will be 2970 upon 2, that is 1485 meter. So this distance, the distance between cliff and the observer on the seashore and the man at the shore, that is y, that is 1450. This is the first part. Okay, and the second part, distance between cliff and observer of the ship on the ship, that is this distance x. So you can put in any one of these equations and calculate x. So x plus y is 1650. We can take that equation. Now, so x will be 1650 minus y. That is 1650 minus 1485. This will be 565. Sorry, 1. This much meter. Okay, so this distance is 165 meter and this distance is 1485 meter. So children, hope you understood that numerical. Now in your book, page 155, question number 10 is of the same type and that will be homework for you. Question number 10 in page 155, it's of the same type and that's a homework for you. Okay, so you're going to try and solve this. Now 11th is also homework. Again, it is very easy, direct sum. Okay, you can do it. So 10th and 11th are homework. 12th I'm going to solve now. Okay, 12th we are going to solve now. This is, I think, 2018. This is also 2018 board question. Okay. Now figure below shows the distance displacement graph of two waves. Compare the amplitude and then the wavelength of the two waves. Okay. So there are two waves, wave A and wave B. You remember the diagram that we used to draw, distance, if it is displacement, distance graph, then this will be wavelength, lambda. This gives you the wavelength, length of a wave, and this gives you the amplitude. Okay. Now, wave A's amplitude is 10. Okay, so they have asked you to compare the amplitude. So when you compare the amplitude, wave A's is 10 is to wave B, that you have to see from the diagram, children. Okay, you see this height, this is the amplitude. For A it is 10 and for B it is 5. Hope you can see this. Okay, so 10 is to 5, that is 2 is to 1. When it comes to wavelength, length of each wave, if you see the wavelength of wave A, one wave's length is 8 meter. Can you see this? This is one wave, its length is 8 meter. For wave B, one wave is going till here, that is 16 meter. Okay, so it is 8 is to 16, that is 1 is to 2. Okay, this is to check whether you know this, that this is the amplitude and this is the wavelength of the wave. Okay, so with this the exercise numericals are over. I'm going to solve one more extra numerical that came few years back. Okay. Now, I want you to note down this numerical. Again, this is not in your book. A person standing in front of a vertical cliff fires a gun and hears its echo after 3 seconds. He then moves away from the cliff by 330 meter and fires the gun again. This time he hears the echo after 5 seconds. Calculate the speed of sound in air. Now this is of the type, now the same type of question you had from the example I solved where he is moving towards the cliff. Here he is moving away from the cliff. Let's see how to solve it. So originally the person was here. He fired the gun from here and he hears an echo after 3 seconds. When he fired from here, he heard the echo after 3 seconds. Now he is moving how much meter away? 330 meter away. 330 meter away, and now from here he fires the gun. Okay, earlier he fired the gun from here, the sound had to travel, go here, come back, it came back in 3 seconds. Now when he fires from here, it takes 5 seconds for the sound to go and come back. Okay, so it takes 5 seconds for the sound to go and come back. Now we are asked to calculate the speed of sound in this medium. Okay, now let's take some x and y and then it will be easy for us to solve. Let's take this distance as x, okay, and this distance as y. This distance as x and this distance as y. So same way, now you will have two cases. One is, let's take this as position A, position B. So at A, V is equal to 2D by T. Now remember here you have to take 2D by T because this is, he produces the sound, it goes, hits here and comes back to him. So it is 2D. Okay. The previous one, the gun was fired by somebody and it was heard by somebody else. So you are not supposed to take 2D by T. Okay, you just took distance upon time. Here, if the same person hears, then the sound has to travel twice the distance. So we don't know V, 2 into this distance at position A, we have taken the distance as x upon 3 seconds. Okay. When the distance is x, he heard the echo after 3 seconds. So this is the first one. Now at B, when he is at B, what is his distance from the cliff? Y. Okay. So again v is equal to 2d by t. So 2 into y by 3. Okay, 2 into y by 5. Sorry, now it takes 5 seconds to reach the, okay, now sorry children, a small correction here. You don't have to take y as this distance, because see, this distance is x, this distance is 330. So what will be this distance? X plus 330. Please don't take another variable, then you can't find any. It will be, you can't find anything. Okay, so this distance, it's enough if you assume this distance as x. So naturally this distance will be x plus 330. If he is moving towards the cliff, you had to subtract it. If you remember the numerical that we did from the example in the book. Now if he is going away from the cliff, then you have to add. So the distance will become x into x plus 330. Okay. So at B, the distance is x plus 330, time is 5 seconds. So you get an equation, you get this like this. Now, because the medium is the same, I can equate these two. Okay, left hand sides are same, so I can equate the right hand sides. 2x by 3 is equal to 2 into x plus 330 upon 5. So 2 and 2 will get cut. So let's take cross multiply it. 5x is equal to 3 into x plus 330. That will be 3x plus 990 is equal to 5x. Okay. So 5x minus 3x is equal to 990. 2x is equal to 990, or x is equal to 990 by 2. That will be 495 meter. Okay, x is 495 meter. But we have to, what we have to find? Speed of sound in air. So you can put it in any one of this thing. So v is equal to 2x by 3. So 2 into 495 by 3. So you cut it 1, 6, 5. Now 2 into 165 will be, is a 10, 330 meter per second. So this is the answer that you will get, 330 meter per second.